And let's continue with the next presentation. We have with us Tuukka Savisalo from Valoe, who will talk about what we've already seen yesterday being presented by IC Constant presenting the Zebra technology, and he shows now how that can be really manufactured. His title is Flexible Manufacturing of Integrated PV Products with IBC Technology. Tuukka, the floor is yours.
Thank you. Let me share the screen. I believe that you should be seeing my screen now.
Yes.
Yes. Thank you, Mr. Chairman, and everybody for giving me the opportunity to talk about our work today. This work is part of the HighLite project supported by European Commission. First, a few words about Valoe. We are a Finnish technology company, and we specialized on photovoltaic technology. We keep on working with the new methods to generate the renewable solar for everybody, and in different innovative ways. We are a listed company listed in Nasdaq Helsinki Stock Exchange with headquarters in Mikkeli, Finland, and we have factories in Juva, Finland, and in Vilnius, Lithuania. In Vilnius, we have an IBC pilot production plant with a capacity of about 80 megawatts. We mainly focus on N-type IBC, and as mentioned before, the ISC constants and the Zebra cell is what we are currently focusing on. And this is we consider this as a pilot factory to work on industrial scale cell processes that are done by the institutes. The factory is extremely flexible in terms of processing sequences and processes, and it enables customization and small series production. Regardless of that, we focus on very high efficiency cells, and our roadmap is to reach 25% efficiency. The ISC constant Zebra cell is the technology that we are focusing now. We are working together with them and also with other institutes to improve this and to make it further. A great thing among other things with the Zebra cell is that it has an interconnection method that is fairly easy to customize to be application specific without completely breaking into the basics of the cell processing. And they are working with a passivated contacts, which you probably heard yesterday. For us, the freedom of design is very important, and that's why we went into cell manufacturing. We can do contacting according to the customer specification. We can do the cell size according to the customer specification, so we can work with very different sizes and shapes of module, and we can give a lot of design freedom to our customers. And another thing that is very important is redundancy. We want to have a module that is very tolerant to damage in many ways, so we can build in redundancy into the module design, because we have also access to the cell design. And we also have the in-house manufacturing of the back contact circuit, which is the back plane, basically a printed circuit board behind the cell, where we do all the interconnections. And the reason why we work with a back contact And that is a decision that we have done, is that it has a very good analogy to surface mount technology that is a well-known manufacturing method in the electronics industry, and we can use a lot of technologies coming from the PCB and electronics manufacturing technology to improve our product and add additional functionalities into the product. And then I will talk about product integrated PV, which is a field that we are focusing heavily today. The product integrated PV can be many things. It involves product and a PV. So the PV will take any shape required by the product design, and the requirements for the product will come from the requirements of the requirements for the PV will come from the requirement of the product. And common traits for this field is everybody wants to have a very good looks, because that is what sells. A high power density is required, low weight is also required, and survivability or resilience is also a desired fact, so that a small defect in the module or in the cell or anywhere there should not affect the system functionality as a whole. The appearance is important, and that's why we like the IBC cell, because it has a very nice and clean appearance, and it helps with the different kind of designs, because we don't have to show those in a customer product. We don't need to show any of the buzzing. Everything is there fully black, and it helps with the appearance, and designers like this look. The high power density is of course important, and that's why we're working with the IBC cell, and also together with ISC constants with the passivated contacts to reach the 25% efficiency. With a high degree of automation, we can approach a very small cell-to-cell spacing, and we don't need to leave any space for buzzing or interconnections because of the back contact backsheet design. The weight is often also a critical part of the product. Nobody wants to increase the weight, even with added functionality. So we need to utilize the existing structure as a back plane, which means that we often go to different kind of polymer structures, sandwich materials. A very thin glass that is now available is a very interesting option, and carbon reinforced composites, of course, reduce the weight, but at the cost. So we need to always make a cost weight rigidity compromise, and that is determined by the customer requirement, and the customer is often who makes the call here. The survivability is what I mentioned, meaning the capability of the product or the system to take damage and still function. And in order to do that, we need to always design redundancy in that. So even if one part of the system goes down, it doesn't affect the next part. And that means that the modules should not be connected in parallel, but in series, but the parallel series interconnection is far better, because then cutting one chain doesn't cut the whole system. And in-module electronics can provide a good path for high resiliency on system level. We work with the product design and the module design, but we also work with the automation and the manufacturability of these things. We manufacture our own equipment, and we can produce the samples and the mass production systems for our customer at the same time. And it is always a good idea to consider manufacturing as an early on in the design to get the best possible outcome in the mass production phase. In the design phase, you often make most of the expenses and get to affect all the surface finish quality and edge qualities. There lack of common standards how to do things is always a challenge, but that can be overcome by hard work. We do offer a full package from the concepting phase to the mass production without our customer needing to know anything about PV. We can do full custom production lines if there are volumes in the product. But we can also do custom manufacturing within our own facilities and our own technical support to start up things. Product lifetime is something that we need to consider very strongly, and is challenging because the way that the PV is changing very rapidly. But the product lifetime can be 10 years or even more, and after design freeze, no changes is normally allowed. And this brings a lot of challenges, especially now when we are seeing a huge fluctuation with the wafer size and thicknesses currently in the market. So in summary, IBC cell is an excellent building block for product integrated PV. A product determines most of the requirements, and traditional PV tools may not apply. High efficiency and attractive looks are the most critical points in any consumer application. And vertically integrated production with flexible production platforms offer extensive capabilities for our customers. Our offering, as far as I know, is unique to the field, where we do co-engineering together with the customer and work all the way to the mass production of the part that has the integrated solar in it. Thank you for your attention, and I want to acknowledge European Union Horizon 2020 program for the support of this work under grant agreement 857793. Thank you.
Thanks, Tuukka. Very nice presentation. There are a few questions in the chat, maybe one from my side. So you're offering basically a turnkey solution. So how is the how do you see demand in the market also for such products? So especially on the cell side and especially also in Europe, companies would like to also differentiate, which they have to do also from Asian manufacturers, and that's why they pick their own stuff. Some companies like Meyer Burger even have their own machinery and do their own do it proprietary. So how do you see response in the market to your offering?
To start things with is that everything's electrifying. The transport is electrifying. Everything is basically electrifying. That generates the need for electricity to be produced locally, and nobody likes to charge batteries if that is not required. In some cases that is inconvenience, but in many cases there are practical constraints for this. For example, you cannot find a suitable place where you have a plug available, or you can extend operating range, or just save labor, keep the batteries working for longer. This need is universal, and with the improvements in solar in the past years, it's the technology is there to do it, and we can see a big increase in demand as the product designers are starting to realize that this is a good opportunity and makes a lot of sense, and can provide extra features and better products.
Okay, thank you. I think there are several more questions in the chat. It would be nice if you could answer them there, and we see you later on for the discussion panel. Okay, thanks a lot.
Thank you.